All right, good morning, everybody. Hope you guys are doing well. Today I'm going to go over the practice problems from 515, which is page 397, 4, 7, 10, 14, 16, 18, 22, 27, 34, 48, and 56. So let's get started. The first one that I had asked you to complete was number 4. And on page 397, number 4 asks you to determine whether each x value is a solution or an approximate solution of the equation. And so the first thing that they wanted you to do for that is they gave you an expression 4e to the x minus 1, and that equals 60. And they said, does, part A, x equals 1 plus natural log of 15, is that a solution? And so let's plug it in and see. So we have 4e to the, now we're going to substitute this in, 1 plus natural log of 15 minus 1 equals 60. And you can see up top we have a 1 and then a minus 1. We have a 1 here and a minus 1 there. So we're going to cancel those out, and you're going to left with 4e to the natural log of 15 equals 60. Now from there we can actually divide both sides by 4. We're going to get e to the natural log of 15 equals 15. Now, from that step, you can see we have something in exponential form, and we are going to take it out of exponential form and we're going to put it into logarithmic form. And so what you can see here is the base of the exponent, that e that I just highlighted, becomes the base of the log, and then this part and this part switch. So log base e is actually natural log. So it's going to be natural log of 15 equals the power, which is natural log of 15. And is natural log of 15 equal to natural log of 15? Yes, it is. So yes, A is a solution. Now let's try it for B. Part B, they asked us to try x equals natural log of 16. So same thing, I'm going to substitute this in, e, and then natural log of 16 minus 1 equals 60. Now you might be very tempted up here to do the natural log of, and then take 16 minus 1 and make that 15. But you actually can't there, because natural log is a member of the exponent family. And in PEMDAS, exponents come before subtraction. So you cannot subtract 16 minus 1 in that. They were trying to get you to, that's why they gave you this problem, but you can't do that. So what you actually need to do is you need to divide both sides of the equation by 4 first. So you're going to have e to the natural log of 16 minus 1 equals, and it's going to equal 15. And then from there, once again, we have an exponent, a base and a power. We're going to change it from exponential form to logarithmic form. So the base of the power becomes the base of the log, and then the other two parts switch places. So we're going to have natural log, so that's log base e, and then of 15 equals natural log of 16 minus 1. Now, once again, you might be tempted to take that 16 minus 1 and do that, but you can't, because natural log comes before subtraction, because logs are part of exponents. So this problem is actually not true. So A worked and B did not. All right, moving on to number 7. Number 7 said solve for x. So we have 4 to the x equals 16. Anytime you have an exponent that is a variable, we need to get that variable down. And the only way to do that is to use logs. Now there's a couple ways to think about solving this problem. I'm going to do it either way. I'm going to show you a couple ways, and you can actually do it either way you want to. The first way, and this would be the way that I would do it, is to recognize this is an exponential equation and we need to convert it into its logarithmic form. And the way you do that is you write log, and you write the base of the log is always the base of the exponent, so at log base 4, and then the x and the 16 switch places. So it becomes log base 4 of 16 equals x. Okay? And then you could proceed to type this into your calculator, and then you would get x equals 2. Now, here's another way to solve this. What you would do is you would actually use the one-to-one property. So you could write 4 to the x equals 4 to the second. And then you can say x equals 2. Now, obviously, this way is the most straightforward way. And so I apologize. Earlier I said the first way would be the way that I would do it. I actually would not do it that way. If I was given a choice, I would do it the way that I just circled. But both of those ways are okay. Obviously, the left-hand side, there's a little bit more work involved because you got to remember your rule to go from logarithmic form to exponential form, and you also need to know how to type log base 4 of 16 into your calculator. So there you go. There's number 7. Here is number 10. Scroll down here a little bit. Number 10 says to solve it, e to the x equals 2. And we're going to solve for x. We're going to get an exact answer. We're not going to worry about decimals here. So again, if there is a variable in the exponent position, I'm trying to condition you guys to take it from exponential form to logarithmic form. And so in this case, you're not going to be able to rewrite the 2 so it matches the e, so they have the same bases, like what I did on the part that I circled in the last problem. So in this case, there's a couple ways to do it. I'm going to show you both. Either way is fine. The first way is the first way that I showed you in the last problem. Take it from exponential form and put it into logarithmic form. And so the base of the power, which is e, becomes the base of the log. So we have natural log, and then the x and the 2 switch places. So there you go. It's natural log of 2 equals x. The other way to take this, and I do want you to be familiar with this both ways, is to log both sides of the equation. You are allowed to do that. Logging is the same as adding 2 to both sides or subtracting 2 to both sides. As long as you do the log to both sides of the equation, it remains balanced and it's fine to do. So you can see this is base e, so we would actually use natural log and natural log. Now by doing that, what ends up happening is this x is allowed to now come down in front of the natural log using the power property. And natural log of e is 1, so that cancels out. And you can see we get x equals natural log of 2. And that's exactly the same as what we got over here. So there are more than one way to do these problems. I'm trying to show you there's a couple ways. And just depending on what you understand, it's fine. Either way is fine to do that. The next one I wanted you to do was number 14. And number 14 was log base 5 of x equals 1/2. Now, when you have a variable in the exponent position, as we did in number 10, you need to take it from exponential form and put it into logarithmic form. Now, this is the complete opposite of that. We have a logarithmic equation that is logging a variable. And so when that happens, you need to take it from logarithmic form and put it into exponential form. And so you can see the base of the log becomes the base of the power, and the x and the 1/2 switch. So this becomes 5 to the 1/2 power equals x. Don't forget, the 1/2 power simply means the square root of 5. And we're going to leave it like that. You're not, don't need to get a decimal answer. They didn't ask for it. Okay, moving on to number 16. Number 16, the directions for the next few, it says, exercises 15 and 16, approximate the point of intersection of the graphs of f and g. Then solve the equations, f equals g of x algebraically, to verify your approximation. Now, unfortunately, because I had issues quite a few weeks ago with my computer, you can't see the book. Hopefully you're looking at number 16. But you can see a graph, and it looks on the graph like that's crossing at a, I don't know, maybe 8, 10. We'll say like at x is 9 and y is, I don't know, 2. So I'm guesstimating that it's 9, 2 from the graph. I'm not exactly positive, but that's what I'm thinking it is. The way we would actually find it is we would set those two equal to each other. So we're going to set f of x equal to g of x. So we're going to set log base 3 of x equal to 2, and we're going to solve it. In order to solve it, you need to take it from logarithmic form, because we're logging a variable, and we're going to change it into exponential form. So the base of the log becomes the base of the exponent, and the x and the 2 switch, and it becomes that 3 to the second equals x. That means x equals 9. And so now that we know x is 9, we can see that that does match what I guessed it was from the graph. We do need the y value though, and the y value is actually set by g of x. The original equation is g of x equals 2. G of x is a fancy way of saying y equals 2. So right there, x is 9, y is 2, and that is what I guessed it to be from the graph. So that's great, it worked out. Number 18, the directions for that one were solve the exponential equation algebraically and then approximate the result to 3 decimal places. So anytime you hear approximate the result to 3 decimal places, you know that there's a very good chance, not always, but there's a very good chance that you're going to have to use your calculator. So we'll see if that holds true for this particular problem. And so you can see these are both exponential equations. They both have the same base. So if the bases are equal and the expressions are equal, it means their powers have to be equal. So we're simply going to write x squared minus 3 equal to x minus 2, and we're going to proceed to solve that. I'm going to subtract x from both sides, and then I'm going to add 2 to both sides, and you can see that I ended up with a quadratic equation. A couple ways to solve a quadratic equation. We can definitely use the quadratic formula, or we can try to factor it, and I believe this one will factor, so we won't actually have a decimal approximation, which is nice. It's going to be x minus 2 times x plus 1 equals 0, and as you can see, x minus 2 equals 0, which means x is 2, or x plus 1 equals 0, which is x equals negative 1. And there are your 2 solutions for number 18. Moving on to number 22. Number 22, the directions for number 22 are actually the same as 17 and 18. So actually, looking through here, all but the last 2 problems, number 22, 27, and 34 all have the same directions. So number 22 is 6 to the x plus 10 equals 47. First thing we're going to do is move the 10 to the other side by subtracting it. And from there, we are going to use some log properties. Here's why we can't use the 1-to-1. If this said 6 to the x equals 36, that would be a very easy one. We could rewrite 36 as 6 to the second, and we could say x is 2. But since 37 cannot be rewritten as a power of 6, there's a couple ways to proceed. I'll show you both ways. Either way is fine by me, the way you do it. The first way is to just recognize we have an exponent or an exponential equation. The variable is in the exponent position, which means if you convert it from exponential form to logarithmic form, you'll get your solution. So that's the first thing I'm going to do. This is the base of the power is 6, so we're going to do log base 6, and then the x and the 37 switch. So it becomes log base 6 of 37 equals x. And this is actually your solution. Now, they did ask you to approximate to 3 decimal places. So in order to type that into your calculator, you're going to need to use the change of base formula, which is log of 37 divided by log of 6 equals x. Now, when you do that, if you give me one moment to type that into my calculator, you get 2.013. Now, the other way to do this problem would be starting right here with 6 to the x equals 37. You could actually take log base 6 of both sides. So if I do log base 6 of 6 to the x equals log base 6 of 37, you can see that I log base 6 of both sides. That's fine because the equation is still balanced. Now on the left-hand side, we have log base 6 of 6 to the x. What's going to happen is this x is going to come down in front of the log because of the power property. And then log base 6 of 6 cancels. It turns into 1, and you're left with x equals log base 6 of 37. And that matches exactly what I said right here and here. These are the same. And then from there, it's the same work. You're going to get 2.013. So it really doesn't matter which way you choose to do that. You can either take it from exponential form and put it into logarithmic form, or you can log both sides of the equation. That's perfectly fine too. Number 27 is 8 times 10 to the 3x equals 12. So we need to peel back the layers, get that x by itself. First thing we're going to do, divide by 8. So we're going to get 10 to the 3x equals 12 over 8. Those are both divisible by 4, so it's going to become 3 over 2. So we'll leave it like that. Now, we have a variable in the exponent position, so you can do one of two things. Just like I did in the last problem, I'm only going to use the first step just because, actually that's not true. I'll show you both ways. So the first way to do it would be to take it from exponential form and put it in logarithmic form. So the base of the exponent becomes the base of the log, so it's log base 10. You don't need to write the 10 if you don't want to. And then the 3/2 switches with the 3x. From there, I'm going to divide both sides by 3, and you end up with x equals log of 3 over 2, all divided by 3. Notice I didn't write log base 10. If there's nothing written there, it is assumed to be base 10. On the other side of that, you can just do log base 10 of both sides. So we have log base 10 of 10 to the 3x equals log base 10 of 3 over 2. And you can see the power property allows me to bring that 3x down. The log base 10 of 10 cancels, so you're left with that. And then we're going to divide both sides by 3, and you're just left with x equals log of 3 over 2, all divided by 3. So you get the same thing regardless of which way you want to do it. Now this is a bit tricky to type in. You want to start by typing in log of 3 divided by 2, close out your parentheses, hit enter, and then divide that answer by 3. And when you do that, you're going to get x equals 0.059, 3 decimal places. So there was 27. The last one of this problem area set is number 34. And so 34 is 8 times 4, 6 minus 2x plus 13 equals 41. We're going to start peeling back the layers. We're going to subtract 13 first. Nope, not 30. It's going to be 28. Then we're going to divide both sides by 8. And 28 over 8, 28 is divisible by 4, as is 8. So it's going to become 7 over 2. Following that, there's 2 ways to proceed. I am only going to do the first way now for this one since it's taken more room up. And that's just to take it from exponential form and put it into logarithmic form. So the base of the power becomes the base of the log, and then the other 2 parts switch. Now from there, I need to get rid of the 6 by subtracting it. So we have negative 6 plus log base 4 of 7 over 2 equals negative 2x. And then I need to divide by negative 2. So I end up with x equals negative 6 plus log base 4 of 7 over 2 all over negative 2. Now that is a very tricky problem to type into your calculator. The way that you're going to type this in is I'm actually going to write what you're going to type in. In your calculator, you're going to type negative 6 plus log of 7 over 2 divided by, whoops, sorry about that, guys, log of 4. Then you're going to take your answer. You're going to hit enter. Then you will take your answer and then do divided by negative 2. So if you give me 1 second to type that in, negative 6 plus, and then it's going to be log of 7 divided by 2 divided by log of 4. And then we're going to divide that by negative 2. We get an answer of 2.548. So there you go. Okay, moving on. 48. Now 48 and 56 come from a different section. In these sections it says solve the logarithmic equation algebraically and then approximate the result to 3 decimal places. So number 48 is log of 3z equals 2. So whenever the variable is in the exponent, you need to take it from exponential form and put it into logarithmic form. Whenever the variable is being logged, you need to take it from logarithmic form and put it into exponential form. So in this case, we're logging 3z. We need to take it out of logarithmic form and put it into exponential form. And that's simply going to take the base. In this case, there's no base written, so it's base 10. The base of the log becomes the base of the exponents, and then the numbers switch. So it's going to be 10 to the second equals 3z. From there, we can expand this and then divide by 3. We get 100 over 3 equals z. It did say approximate the result to 3 decimal places. So when you do 100 divided by 3, you get z equals 33.333. All right, now the last one from this set is number 56. And number 56 is natural log of x plus natural log of x plus 1 equals 1. Now this one's going to utilize the product property. And the product property allows us to condense but also expand using the whenever you're logging a product, or if you have 2 logs that are being added together, you can create a product, which is what we're going to do here. So you can see we have log of x plus natural log of x plus 1. I'm sorry, it's natural log of x plus natural log of x plus 1. So this can actually become 1 natural log, and it becomes x times x plus 1. And that equals 1. So we utilize the product property, but kind of in reverse, so we condense this expression down. From there, I'm going to distribute that x. So we're going to have natural log of x squared plus x equals 1. And now we've got an expression we can deal with. So we have log of variables. Anytime that happens, you move them into exponential form. So the base of natural log is e, so this becomes e. And then the other 2 things switch places. To the first power equals x squared plus x. Now from there, you can see e to the first power is actually it's a number. It's an irrational number that goes on forever. We're actually going to subtract e to the first from both sides, and we're going to get 0 equals x squared plus x minus e. Now, this is a quadratic equation that you would like to be able to factor, but you can't. So you have to use the quadratic formula for this one, which is x equals, and I'm going to go back a second. Identify A. A is 1 in this one, B is 1, and C is actually negative e. So the quadratic formula is negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Now, condensing that down, -1 plus or minus, you can see that is 1 squared, which is 1, minus 4 times -e. So this becomes 1 plus 4e over 2. And that right there is what you're going to type into your calculator. You really can't condense that anymore. But there's two answers in one. First, you have to type it in with the plus, and then you need to type it in with the minus. So in doing that, you're going to type -1 plus the square root of 1 plus 4e. You want to close out your parentheses, make sure, and then all of that's going to get divided by 2. And when you do that, you get x equals 1.223. But there's a second answer, and that second answer is you need to go back and change the plus to a minus. And when you change the plus to a minus, you get -2.223. And there are your 2 solutions for that one. So that one was definitely tricky too. So, all right, guys, hopefully that helped, and I hope you guys are all doing well. We'll talk to you soon.